Welcome to lecture 5 of continuous bivariate random variables. Question is shown in the figure is a region in the xy plane where bivariate PDF fxy of x comma y is equal to c, 0 elsewhere. What is the value of c? Evaluate fxy of 1 comma 1, which is joint CDF. Find the PDF of x and y. In case of bivariate random variable, PDF of x and y means it is the marginal probability density function of x, fx of x, and marginal probability density function of y, fy of y. Are x and y independent? So here region means that x and y values for which the joint probability density function fxy of x comma y is defined is shown in the figure. So first, by looking at the figure, you have to identify x and y values for which fxy of x comma y is a c and for which it is 0. So see the figure, shaded part. Now to identify x values in the shaded part, the least x value is -2 and the highest x value is +2. So x varies from -2 to +2. When you say x varies from -2 to +2, then along with this shaded part, a little portion of unshaded part is also included. So we want only the shaded part from x is equal to -2 to x is equal to +2. Along with the shaded part, unshaded part is also included. So while choosing y, you have to choose y in such a way that this unshaded part will be excluded. So you can't take y from least value -2 to highest value +2. If you take y from -2 to +2, then the unshaded part gets included in it. So you can't choose y as -2 to +2. Up to +2 is upper bound 2 is correct, but lower bound it cannot be -2. So see this line boundary which passes through region which comes in the first and third quadrant. In the first quadrant, both x and y are positive. In the third quadrant, both x and y are negative. So the line passing through origin in the first and third quadrant is given by the equation y equal to x or x is equal to y. So while taking y, let it start from this boundary, that is y equal to x, vertically upwards up to 2. While choosing y, let it start from this boundary y equal to x, vertically upwards to 2. So shaded part will be x is equal to -2 to x is equal to +2. Why we have to take x as +2? Because this vertex is included. To exclude this unshaded part, you start y from y equal to x, vertically upwards to y equal to 2. Then the region will be only the shaded part. X alone is from -2 to +2. Y means it is x to 2. When you take both, the common region will be this shaded part. If you take x alone, then you need to take x from -2 up to y, up to this boundary which is x is equal to y. X starts from -2 up to y. X is equal to y, -2 to y. When you take x alone, it is x is equal to -2 to y. Y will be x to 2. So When you take both, the common region of will be x is greater than or equal to -2 less than or equal to 2, y is greater than or equal to x less than or equal to 2. Then to find C, fxy of x comma y is the joint probability density function, means double integral of that from -infinity to +infinity must be equal to 1. Now inner integral will take it with respect to y, outer integral with respect to x, because limits of x are purely constant. Limits of y consist of the variable. So for outer integral, limits of integration must be constant. So we'll take outer integral with respect to x. So it is integral from -2 to +2. Inner integral from x to 2. fxy of x comma y is c. dy dx equal to 1. C is kept outside the integral sign. C into integral from -2 to +2. Integral dy is y. Difference at the upper limit to lower limit x dx equal to 1. And integral difference of y at 2 and x is 2 minus x. So that should be equal to 1. Now integral of 2 is 2x minus integral of x is x square by 2. Difference at upper limit to lower limit -2 equal to 1. C into putting x as 2, it will be 4 minus 4 by 2 is 2. 4 minus 2 is 2. Then it is minus. Putting x as -2, it is -4 minus x square by 2 means -2 whole square by 2, which is 4 by 2 or 2. -4 and -2 will be -6. So minus of -6, here it is +6 equal to 1. So C into 8 is 1, or C will be equal to 1 by 8. Second part, the joint CDF fxy of x comma y is, by definition the formula -infinity to x integral -infinity to y fxy of x comma y dy dx. But x is from -2. Outer integral with respect to x, and the region starts from -2. Y starts from x. So now we want fxy at 1 comma 1. So put x as 1 and y as 1. It is integral -infinity to 1. Integral -infinity to 1 fxy of x comma y dy dx. Since outer integral with respect to x, x starts from -2. You start the lower limit of the outer integral as -2. For other values less than -2, you ignore it, because for that other values this fxy of xy x comma y will be 0. So that double integral becomes 0. So you take only those x values where the double integral remains to be non-zero. So lower limit you start from -2 to 1. Upper limit of x is 2, and this 1 is clearly less than 2. Similarly for integral with respect to y, lower limit you start from x. fxy is c. Keep a c outside the integral sign. Then integral dy will be y, difference at 1 and x, which is 1 minus x. Integral of 1 with respect to x is x, minus integral of x is x square by 2. Difference at upper and lower limit. C into put x as 1. 1 minus 1 by 2 is 1 by 2. Then minus. Put x as -2. -2 and -2 square by 2 means 4 by 2, which is 2. So -2 and -2 is -4. So here it will be half minus of -4, half plus 4. C is 1 by 8. Half plus 4 is 9 by 2. So it will be 9 divided by 16. Third one. Joint marginal probability density function of x fx of x. By formula it is this integral -infinity to +infinity fxy of x comma y dy. Remember, marginal probability density function of the continuous random variable x. It is this integral with respect to y. Marginal probability density function of x, integral with respect to y. So y values is from x to 2. So integral from x to 2, in that case fxy of x comma y is c. Keeping c outside the integral sign. Integral dy is y. Difference at the upper limit to lower limit x. So c into 2 minus x, but c is 1 by 8. 1 by 8 into 2 minus x. Similarly, marginal probability density function of y, fy of y, integral from minus infinity to plus infinity, fxy of x comma y dx, marginal probability density function of y and integral with respect to x. Now x value will be, if you see the figure, look at only x value horizontal in the shaded part. X value will be from minus 2 to y, to that line x is equal to y. So only x value means horizontally it is minus 2 to y. C dx. C is 1 by 8 into integral dx means it is x, difference at y and minus 2, which will be y minus of minus 2, y plus 2. So c into y plus 2, c is 1 by 8, so 1 by 8 into y plus 2 is fy of y. Then the last part, are x and y independent? If we multiply this fx of x and fy of y, if we multiply these two, it will not be equal to fxy of x comma y, and fxy of x comma y is 1 by 8. This product is not 1 by 8. So that's condition, the joint probability density function fxy of x comma y is not equal to the product of the marginal probability density function fx of x into fy of y. Condition not satisfied, so x and y are not independent. Next question. The joint PDF of a bivariate random variable x and is given the joint PDF of bivariate random variable x and y is given by fxy of x comma y is key for the values of x where y is greater than 0, less than or equal to x, and that x is less than 1. So both x and y lie between 0 and 1. Find the value of key. Now again, what must be the value of key? Given that this fxy of x comma y is the joint probability density function of the continuous bivariate random variable x and y, then the condition is double integral of this fxy of x comma y from minus infinity to plus infinity must be 1. So take that condition. Now here y is greater than 0, less than or equal to x. So for inner integral with respect to y is greater than 0, less than x. Y is from 0 to x. Outer integral with respect to x, and x varies from 0 to 1. So that integrand fxy of x comma y is key. Keeping k outside the integral sign, k into that double integral, which is equal to the right hand side is 1. K into integral dy is y, difference at the upper limit x and lower limit 0, which is x minus 0 or x. So k into integral 0 to 1 x dx is equal to 1. Integral x dx is x square by 2, difference at the upper limit 1, lower limit 0, right side is 1. So k into, put x as 1, 1 by 2, minus put x as 0, 0 by 2 or 0. Half minus 0 is half. K into half is k by 2 equal to 1, or k will be equal to 2. Then marginal probability density function of x and y. First fx of x as before, the same formula, integral minus infinity to plus infinity fxy of x comma y dy. So here you need to consider y values which are from greater than 0, less than or equal to x. So integral from 0 to x, fxy of x comma y is k and k is 2. So keeping that 2 outside the integral sign, integral dy is y, difference at the upper and lower limit 2 into x minus 0 or x. So we get fx of x as 2x, and this x value is from between 0 and 1. And that fx of x is 0 for other x values, because for other x values the integrand fxy of x comma y in the formula of the definition of fx of x will be 0 for all other x values. So integral becomes 0. So fx of x is 0 for other x values. Similarly, fy of y, integral from minus infinity to plus infinity fxy of x comma y dx. Marginal probability density function of the continuous random variable y is integral with respect to x. Now here you need to consider x values. X varies from between y and 1, and clearly y is greater than 0. It varies from y to 1. So integral from y to 1 fxy is k means 2 dx, keeping 2 outside the integral sign. Integral dx is x, difference at y1 and y. So 2 into 1 minus y. So fy of y is 2 into 1 minus y for all the y values between 0 and 1. And it will be equal to 0 for other x, y values. Then the third one, probability that x is greater than 0 less than half and y is greater than 0 less than half, which will be equal to probability that x takes value greater than 0 less than half, y will be greater than 0 and less than or equal to x. X is clearly less than half. So when you say y is less than or equal to x, as said in the question, and x is less than half, then y will be greater than 0 less than half. So here y should be less than or equal to x. Now calculation of the probability for a bivariate random variable when that both variables are continuous is calculated through double integral. So double integral with respect, outer integral with respect to x, inner integral with respect to y. So for outer integral, limits of integration is 0 to half. For inner integral, limits of integration is 0 to x. So fxy of x comma y, integrand dy dx, integral 0 to half, integral 0 to x, k, integrand is k means 2 dy dx. So 2 is kept outside the integral sign, integral 0 to half, then integral dy is y, difference at the upper and lower limit x and 0 dx. So take the difference, it is x minus 0 or x, and integral of x with respect to x is x square by 2, difference at half and 0. 2 in 2 gets cancelled. So difference of x square at half and 0, put x as half square is 1 by 4, minus 0 means 1 by 4. Then the question is, next question, a manufacturer has been using two different manufacturing processes to make a computer memory chip. Let x and y be bivariate random variables where x denotes the time to failure of chip made by process E, y denotes the time to failure of chip made by the process B. So a manufacturer has been using two different manufacturing processes to make a computer memory chip. So here we take x as the time, x and y as a bivariate random variable where x denotes the time to failure of chip made by process E, means the expiry time. The expiry time of the chip which is made through process E, and y denote the time of to failure of chip made by process B. Now assuming that x and y, assuming that joint probability density function of x and y is equal to fxy of x comma y is ab into e power minus ax plus by for x greater than 0, y greater than 0 and 0 otherwise. For all positive x and y values, fxy of x comma y is ab into e power minus ax plus by, where a is 10 power minus 4, b is 1.2 into 10 power minus 4. Find the probability that x is greater than y, or find the probability that y is less than x. Probability that x is greater than y or y is less than x. Here for bivariate random variable x and y, the probability is calculated through double integral because x and y are continuous bivariate random variable. So probability is calculated through double integral. Outer integral with respect to x, inner integral with respect to y. For inner integral, the limits of integration is y is greater than 0 and less than x. So integral 0 to x. Outer integral x is greater than 0, no upper limit, so 0 to infinity. fxy of x comma y dy dx. Now fxy of x comma y means ab into e power minus ax plus by. So ab is constant, can be kept outside the integral sign. Integral 0 to infinity. Inner integral. Here with respect to y. So e power minus ax kept as it is. Integral of e power minus by dy from 0 to x dx. And integral of e power minus by with respect to y is e power minus by divided by the coefficient of y, which is minus b. Difference at the upper limit x, lower limit 0. So b gets cancelled, minus sign with a. So it is minus a. Integral 0 to infinity e power minus ax into difference of e power minus by at x and 0. Put y as x, e power minus bx minus, put y as 0, e power 0 is 1 dx. So minus a into integral 0 to infinity, multiply this, e power minus ax into e power minus bx, e power minus ax plus minus bx, or e power minus of a plus b into x, then minus e power minus ax into 1, e power minus ax dx. Now integration of e power minus a plus b into x means e power minus a plus b into x divided by minus a plus b. Integration of e power minus ax is e power minus ax divided by minus a. Difference at the upper limit infinity, lower limit 0. So minus a into at upper limit infinity, put x as infinity, e power minus infinity will be 0, so this term is 0, minus e power minus infinity is 0, so 0 by minus a means 0, that means at the upper limit whole bracket will be 0, minus at the lower limit put x as 0, e power 0 is 1, 1 divided by minus a plus b, then minus put x as 0, e power 0 is 1, 1 divided by minus a. So minus a into minus minus plus 1 by a plus b, minus minus minus, 3 negative sign means it is again minus 1 by a. Subtract this. Denominator will be a plus b into a. Numerator is a minus a plus b. A cancels, minus b remains. So minus a into minus b will be plus ab divided by a plus b into a. Here a cancels, so remaining is b divided by a plus b. B is 1.2 into 10 to the power minus 4 and a plus b. A is 10 power minus 4. 1 time 10 power minus 4 plus b means 1.2 times 10 to the power minus 4. Sum will be 2 plus 2 times 10 power minus 4. 10 power minus 4 cancels. 1.2 divided by 2.2, which is 0.545. So the probability that y is the the probability is 0.545 or 54.5%.